Hello everyone. In today's lecture, we'll be discussing the PIR sensor and its interfacing with the Arduino Uno. We'll also be testing it on Tinkercad and running a simulation. So first of all, let me start with telling you about the PIR sensor. So the PIR sensor stands for the passive infrared sensor, and it is used for detecting movement of human beings and other objects. So it is widely used in automatic applications where there is some sort of action required whenever a movement has been detected. So that is one of the uses for this. So the way it works is that it has two pyroelectric sensors that are sensitive to the infrared radiations that are reflected and emitted by living and non-living objects. And based on that, it gives a signal to our Arduino Uno board. And every time an object has been detected, it gives a high, logic high. And every time an object goes out of its range or there is no object within the vicinity of the sensor, it gives a logic low. And one of the other things is that it has a special kind of lens called the Fresnel lens, which really gives it a wide range of view. So its ability to detect objects is much higher than the infrared sensor module that we talked about in a lecture a while ago. And that is one of the advantages of this sensor. It also has a potentiometer so that you can fine tune the output and accordingly set the threshold limit. So without further ado, let's get on to the circuit diagram of this. Let's actually make it in Tinkercad as it is one of the components that is available over there. So here we are in our Tinkercad, and let's just start with driving our main components first. So we'll be getting an Arduino in our workspace. Next, I'll be looking for a PIR sensor. So this is what a PIR sensor looks like, and it has 3 pins. So this is the signal pin, this is the power pin, and this is the ground pin. So let's just make the connections over here. So this is the signal pin, which we will be connecting to our pin number 4 on the Arduino Uno board. So digital pin, we'll be looking for digital output here. The power pin goes to 5 volt, and our ground pin goes to the ground. So we'll also be changing the colors a bit, and let's just make our circuit a bit cleaner. So as we know, ground is black. Let me just do that real quick. And red is for our VCC, which is the 5 volt for powering the PIR sensor. So I'm just going to make this red, and let's just leave our signal wire as blue. So with this, our circuit diagram looks good, and we can move on. So this is our circuit diagram. Now let's actually go to our code and write it down. So we'll be writing a text-based code. So let's just go to text. So what is the objective of our program? We want that anytime some sort of object has been detected, our onboard LED turns on. That is what we've been doing with all the sensors. And every time we want to actually drive a, let's say, appliance what runs on higher voltage, we can use a relay module, which we talked about before as well. So in order to start with our code, we're going to obviously use the digital read function to read whatever the output is being sent by the PIR sensor. So by now you might have noticed that how whenever we are using the digital read function, the code is somewhat similar. We always assign a variable and store the value of the digital read function, and then we use an if statement. So this code is just going to be the same as our push button or the infrared sensor. So let me just still explain it to you and write it down. So first of all, we are declaring pin number 13 as the output, where the digital LED has been connected on the Arduino Uno board. Next, we'll be turning it off in the starting. We will also be declaring our pin 4, where the PIR sensor has been attached, as the input. And we'll also be creating a variable. So let's just create a variable, say int temp, and in the void loop function, we'll be giving temp the value of digital read. So we've done this code pretty much a lot of times. So I'm sure that you'll be able to write this yourself as well. So feel free to pause the video anytime you want to and actually run the simulation by yourself as well. So now we're going to say if temp is equal to 1, which means that every time an object has been detected, we want to turn the onboard LED on. So that's what we're going to do. We're going to write digital write 13i. So we'll be using else statement here to say that okay, if we are getting a low, which means that there is no object being detected, we want our onboard LED to stay off. So let's just do that as digital write 13 low. So with our code looking good, let's actually start with our simulation. So starting the simulation, and so on pressing the PIR sensor, this is the object, the green ball over here, and as you can see, this is the field of view of the PIR sensor. So I'll be showing that to you. And whenever an object is detected over here, as you can see, the onboard LED turns on. Over here, the onboard LED is on, right? So as the object is detected, the onboard LED remains on, and as soon as I take the object outside the range of the PIR sensor, the onboard LED turns off. Inside the range, the onboard LED is on. And assuming there is no movement detected for a while, see how the onboard LED turns off over here. Because even though the object is over there, there is no movement. So the PIR sensor is a movement detector, not an object detector as compared to the infrared sensor. So as you can see, since there is movement, I am getting onboard LED as high, and as soon as it either walks out of the range of view, I get it off. And let's say if even though it is in the vicinity of the PIR sensor, but it is not moving, the onboard LED will turn off. So with this, we come to the end of the PIR sensor, its interfacing and its simulation.